see what we have covered. I think you will, you will realize that I don't know if you can see my screen. Are you in the position to see my screen? One person unmute and tell me if
Yes.
you can see my screen.
Yes.
Yeah.
Okay. So I want to show, yeah, thank you. Let us go up to the certification. You see how much we have covered so that we can go ant in ant so that you can see, yeah, it is Python entry level. And after the lesson, I will expect you to advise me if we follow strictly what is in the certification, because uh, in my survey, I realized that is one of the reasons why some people are running away. This is now the content in our certification. This is the content. The first module, it talks about the basic concepts. And the basic concept, I think we have covered, because the basic concept, it is in chapter 1, which is purely theoretical. And I didn't teach that theoretical part since I expected each and everyone, you can just read it by yourself. There is nothing like coding in that chapter 1. It is highly theoretical. You have just to know what is the reason behind programming, what is semantics, interpreter, lexis, semantics, syntax, and that is purely in chapter 1. Then in chapter 2, we cover about an integer, boolean, float, scientific notation, string. Then we covered what we call comment, the importance of having comment in a code. We covered the print function, we cover the input. Then we cover other numerical system, where we cover the unary and binary. We covered decimal. This decimal, I told you, it is just a float number. Then we cover the arithmetic operations, such as greater than, plus, that what have you. So everything in that chapter 1 we have covered in that module 1. That is basic concepts. And in the certification, it will only have 5 questions. Evaluation, basic input and output operations. I think we covered the unary and binary. Then we covered the bitwise. That is where we add um, that those signs like this. We covered them. So in Boolean expression, we covered a number of them, where we covered the conditionals, what and what have you. We covered this operation, such as is equals to, not equal to, greater than or is equals to, less than or less than, and is equals to. We covered the accuracy of floating point numbers, and I told you the limit. We covered the input, print, int, float, string, then the length functions. Then I remember I told you the different formats of print, where you use uh, and where you use the argument sep. Also, we covered the basic calculation, and we covered string and how to assign them, index them, and how to do immutability. Then we have also covered control flow, and under control flow, we have covered loops, conditional blocks. We have covered if else, if elif. Then we have covered iteration, and in that iteration, we have covered while, for range. Then we have covered how what we call sequences. Then we have covered the nested loops, and also controlling the loop functions. And in this chapter 4, we just cover in this module 4. We have just covered a little bit of tuples, but in chapter 9 we'll cover list, tuples, and dictionary in details. So and right now we are covering functions. We are covering function. So basically, in these 5 modules, I think we have covered 3 of them fully. We are in the 4th one, and then now the last one, which we'll cover in chapter 8 and chapter 9 and 10, it will be this one now in module 4, what we call data collection. So that is it. So I will use a different approach, but after the lesson, I might seek some more advice from you. But you will realize now I'll be skipping some more complex examples, which I think it will not be quite relevant, so that we can reduce the case of people running away. Now, in our last lesson, I introduced you on functions, and I told you the first function that we are going to deal with, it will come from the math library. And I told you the different ways of how to I think I had been thrown out of the meeting. I don't know why. Let me share again my screen. Now, what I'm saying in our last lesson, I introduced you to the topic of function. And I told you now in function, one of the library that we'll be dealing with is the math library. And I taught you 3 different ways of how to import this math library. And I think I gave you some example of how to calculate square root, how to calculate cos, sine from the math library. So today I'll give you more examples of how to do the same. Now, for example, now you want to make a program, and this program, you want to make a program in such a way it has to compute a square root. So the first thing, you have to import now the square root function from the math library. How will you import it? I said you can say from how I've written it here, I have said from math import star. So when you say from math import star, it means now math library will come out with each and every function within the math library. But when you want to specify that you only want it to come up with a square root, you will just say from math import sqrt. SQRT in Python programming, that means you want to compute square root. So you'll say from math import star. So that means that math library will come up with everything. Then we call the number which the user will enter a numerical. That is just the short form of numerical. Is equal to eval. And I've been telling you time and again, eval, it means this program will either accept to compute square root of a positive, not a positive, of either an int or a float. Then now you want to get the root. So you'll say root is equals to sqrt. And that sqrt now is the function, which means square root in Python programming. So you say sqrt bracket num. So it means you want to get the square root of a certain number, which has been denoted num. So when I will enter, and I enter a number such as 89, and I press enter, it will compute for me the square root, and it will give me now the number which I have entered is 89. And when now it computes the square root, it is 9.43398 in that order. The same way, now you see up there, I've imported SQRT using the star sign. But in the second case, I want just to specify it only comes with sqrt. It doesn't come with any other function within the math library. So the second way you can do it, you'll say, now from math, import sqrt. Now, it means you are going to compute square root. So this function, for example, you see here a variable x has been assigned 16. So when you want now to get now the square root of this 16 to be displayed, you can just say print sqrt. Then the first way you can say 16.0, or you can call it by using now the what? You can call it by using the variable x. In this second case, you have seen I've called it by saying now print sqrtx. So both of you see in this first one, I wanted the square root to be printed, but I've fed my program with a float number. But now in this second case, I'm calling now the variable x, uh, the variable x, and in this x, I'd assigned it 16. Now, also you can compute the square root by using now a parse expression. What is a parse expression in Python programming? That is where you have been given the square root of maybe 2 multiplied by x minus 5. That is a parse expression where you have a mixture of numbers, numerical values, and variables. So that means at first we want, if you want to compute the square root and you follow all these three ways, you will get the square root, because in this one you see I want to get the square root of 2x minus 5. And then this value of x here is 16. So this means it is 16 multiplied by 2, which is 32, minus 5, which will get 27. So it means here it will compute the square root of 27. Here it will compute the square root of 16, and here it will compute the square root of now a float value, which is 16.0. Then here, I want now to assign results to a variable, and then it computes the square root. So what will I do? You see here I've assigned my variable is y. I say y is equals to sqrt x. And you see now this sqrt x, uh, my value for x is equals to 16. So it means now it will compute when you say y is equals to sqrtx, and you want now to call the value of 1, it will give you now the square root of 16. So when I run, you will realize when I first started by finding the square root of 16.0, it gave me 4.0. Then when now in the second case, I was finding the square root of 2 multiplied by x minus 5. And I've told you 2 multiplied by x is, and our x is 16, that is 32, minus 5, it becomes 27. And when you use your calculator, you will find out that the square root of 27 is 4.19. Then on our last example, you see that y is equals to sqrt of x, and the square root of x, and our x is 16. That means now the square root of y is 4. So that is basically what we use when computing square root. In the other example, I want to, you see here I've assigned my x is equals to 16. Now I have an expression, and this expression mathematically I've written it to multiply by the square root. So if we have here teachers of mathematics, there is that square root sign that looks like a small tick. So instead of you putting that square root sign, Python doesn't recognize that square root sign. So you write 2 multiplied by sqrt, then bracket x plus 16 minus 4. And you have to bear in mind, you had assigned the variable x a value 16. So it will just compute it, and it gives you now the square root of this expression. And our expression is y is equals to 2 multiplied by the square root of x plus 16 minus 4. So when you run, it will just give you the results. The same way now here, there are some arguments. For example, sometimes you might get an expression written as y is equals to the square root, then bracket square root of 256. So it means this 256, it is undergoing, it is being square rooted double. So when you will run, it will just give you 4. It will just give you 4. Because the square root, at first, the square root of 256, I think, is 16. Then you have seen this square root twice. So it means the square root will be done twice. Then in this example, it is just the same way as what you are doing, I think, in chapter 2 or 3. You see here, I've written now, I want to get the square root. And this square root, you see this number 45. This 45, I've written it in a string form. And you know you can't find a square root of a string. Why have I written it in a string form? Because it is under quotation mark. So when I just run it that way, without specifying that this number should first be converted to an int, it will give me an error. It will give me an error. But now, you see, after I've written it under quotation mark, outside here I've put an int. So it means now it is practically possible, because square root can only be done for floats or integers, but not string. So when I run, you see it will give me now the square root of 45 is 6.7. But now look here, in this second case, I want to find the square root of 45, which is a string. But in this case now, I've not specified it for it to change to an int. So when I will run this line of a code, it will give me an error. It will give me an error. You see it has given me an error, and that error is type error. It says must be a real number, not a string. So this means for you to find a square root, it must be a real number. It should not be a string. And what do I mean by a real number? A real number, it should either be an int or a float. It should either be an int or a float. But you see here, when I've run the same here, it gave me the square root is 6.7. Why has it given me the square root is 6.7? You see here, I've written this 45 in a string form, but before that 45, I've put there an eval function. What is the meaning of this eval function? From our chapter 3, you saw that when now you put an eval function, this means that it can either accept float, string, or an int. Now, because square root can only be determined on a float or an int, so that is the reason now it has accepted square root of this 45, and it has given me 6.7. In this case, automatically now, in this other example, it will give me an error. It will give me an error. Why will it give me an error? You see, let me run it first. Yeah, it can give me an error. You see now, yeah, in this case, it won't give me an error because of one reason. Why will it not give me an error? You see now here, I've written this 45, and this 45, I've written it in a string form. But as I've told you earlier, square root can only accept a float or an int. Now, you see here, I've started by specifying that it should be a float, and that quantifies it to be accepted by a square root function, because a square root function in Python programming can either accept a float or an int. Now, in this case, as said from math import sqrt. From math import sqrt, then I want to get the square root of 16. And this 16 is a string. Why is it a string? I've written it inside the quotation mark. So it will give me an error. Why will it give me an error? You can't find a square root for a string value. So when I run, you see the error is, you can get, I get an error that way. Now, the second thing I want to teach you about square root. When you are computing square root, you can only compute a square root for a single number. You can't compute a square root and you are giving a list. For example, in this case, when I'm computing the square root and I want to get the square root of 5, 7, it will give me an error, 5, 7, etc. It will give me an error. Why? You can't find a square root of values which are more than 1. You have just to find a square root of one number. That is one condition in Python programming. So when I run this, you realize it will give me an error. Why is it giving me an error? What type of an error? You see, it tells me math.sqrt takes exactly one argument. It takes exactly one argument. But as you can see here, it will give me an error because it has got two arguments, 10 and you separate 10 and 20 separately, it will run and give you now the results. So what you should know in square root function, it takes only one argument. The second thing, square root argument is only applicable for integer and float values. It is only applicable for integers and float value. When you try to feed it with a string value, it will give you an error. And now look here, when I try to get square root of 16 inside the quotation mark, it will give me an error because it is a string. But now in this second case, I've put this 16 under quotation mark, but before this year, I've put an int. So I'm specifying that that number 16 is not a string, it is an int. You see, it will give me the square root. The same here, I've specified it to be a float because I've told you it only accepts an int or a float. It will also accept. And in the third case, I've put an eval. And from the definition of eval, you know it is a function that it can accept either a float, int, or a string. Since now it qualifies to be in those two requirements, it will compute the square root and it will give me 4. Now, we have finished with a square root function. Now, the second function which we are going to cover, it is a random function. It is a random function. Let me see about random function a bit. Now, the second type of, we have finished the first type of a function, it is square root function. The second type, we are going to random function. So you have to know that some functions do not accept any parameter. For example, the function to generate a pseudo-random floating point number, random, requires no argument. So when you want just to generate random numbers, it requires no argument. It requires no argument. So in this case, that is where now we come. Where that is where now we come with the random function within Python programming. And when you want to come with the random function, it is the same way which we have been how we have been generating functions from the math library. So this random function also comes from the random library. So you have to import it first. You'll say from random, import random. And then after you import random, we want to generate just a random number without any parameter being specified. Let me run. You see, when I just say random, you have seen I've not put any argument in between it. Now, you have to know that the random function is part of the random package. the random function return a floating point value. You have seen it has returned a floating point value. This 0.196 is a floating point value, but the client does not pass the function. The client does not pass the function any information to do its task. You see, I've not passed it with any information. I've just written random, and I opened and closed the bracket. So any attempts when you will try to pass what a function inside it, when you try to pass a function inside it, it will give you an error. It will give you an error. For example, in this case, you see now, I want to import the random function, and you see I've said from random import random. In this case, instead of me writing random uh, with null brackets, or what can I say, with nothing inside the bracket, I've decided to include 3. When I've decided to include 3 and then see when I run, it gives me an error and it tells me one argument has been given. So when you are using a random function, you need not to pass any argument. But if I will just do it that way and I run, you see it has given me a floating point value, which is 0.25, which is 0.25. But when I try to include something like 4 inside, it will give me an error. You see, when I try, and this random number, it keeps on changing. It is not constant. When I run this again, you see it is 0.3. When I run it again, 0.96, it keeps on changing. It keeps on changing. So the random function doesn't require any argument within the bracket. So like I think that one, yeah, let me cover something. Yeah, like mathematical function that must produce a results. Python function always produce a results to return to the client. Some functions are not designed to produce any useful results. Client calls such function for the effects provided by the executing code within a function, not for any value that the function computes. The print function is one of such functions. So you have to know that the print function, it is one of the functions within Python programming. The print function displays the text on the console window. So the work of the print function is just to display the text on the console window, so that or to display the text on the screen. It does not compute and return a value to the client. So you have to know that a print function doesn't compute or return a value to the client. For example, you see I've said print, then I've said print 4. So that I want to show that it doesn't compute or returns a value to the client. It is just there for displaying results on the screen. So that is why here you have seen it has written print. When I've written print, then print 4, it has printed that 4, then said none. What is the meaning of this none? It means it doesn't compute. This print function doesn't do any computation. It is just a function within Python programming for displaying. Other standard function in Python programming, which I want you to know. The first one, which I've taught you, it is the square root function, and I've taught you the random function. And earlier, and also I've taught you what? I've taught you the POW function. Earlier in this course, I taught you the POW function. Earlier in this course, I taught you the POW function, and the POW function is just to compute the power. So what I've taught you up to this juncture, it is square root, cos, POW. Also, I've taught you the sine. Now, the other thing in addition, which during your free time, you need to be doing it, it is the exponential. then the log, then we have log to base 10, then we have degrees, we have radians, then we have absolute. In Python programming, when you want to compute an absolute, we normally say fabs. We normally say fabs. That is a function in Python programming. And you do it the same way. For example, I want to compute an absolute. I'll say from math, import, then I put that star. Now, what will it mean? It means now this one, it will come up with any function, any mathematical function. Then I want to say now fab. I think it is fabs, yeah. I'll say fabs. Then 4. So that means it will just compute the absolute. When you want to compute an absolute value, you use fab. Then when you want to compute an exponential, for example, we want to compute an exponential, just say exp. That way. You have seen exponential computes e raised to a power. So maybe you want to raise it to 10. Our power is 10. So it will give you that way. Maybe you want to compute a log. And yeah, you just do the same way. So the easiest way of importing all those functions within math library, you say from math import star. So it will come out with everything. So this is just a mathematical equation which applies the use of those functions which are violated above. It is just a mathematical question. For example, you have got any mathematical question, maybe in book 4, book 3, or college mathematics, you want to do it with Python, you have to apply those mathematical functions. So this is quite deep, and as I've told you, there are some things which are in advanced. I'll be skipping them, but if you just see that it is good for you to pass through them, I just encourage you. Now, the other thing is time function. I'll teach you about time function. The time package contains a number of functions that relate to time. We'll consider 2, that is clock and sleep. So in time function, we are only going to consider 2. There are a number of them, but we'll just consider the clock and sleep. You have to know what is a clock function within the time function and the sleep function within the time function. The clock function allows us to measure the time of parts of a program execution. So it just allows us to see how much time the program has taken to be executed. Now, you need to know that the clock function returns a floating point value representing elapsed time in seconds. So when you want to run a clock, when you want to run now a clock function, this is in fact, let me see, in the recent version it was changed. Yeah, thank you a lot. In the recent version it was changed. It is not known as clock, it is known as process time. It is known as process time function. So I want you to note, let me just change here. Let me write it process time. It's known as process time. It was changed from clock by these people from Python Institute. It is process time function. I think, what am I writing? A little bit so that I can see it. Yes, yeah, thank you. Give me a minute. Let me write here process time. Process time. Yeah, now it is correct. So in time function, we'll cover two. One is process time, and the second one is sleep. So I have not changed here, please, a little bit. Let me change here to process time. Yes, thank you. So the process time function allows us to measure the time of parts of a program execution. The process time, as I've told you, it returns a floating point value representing elapsed time in seconds. So for example, I want to make now a program that it will cover the process time. So how will I import? I'll say from time. Now this one, now it comes from the package of Python known as time. So you say from time, import process time. Then print enter your name. Print enter your name. For example, I want to measure the time which it will take to process now when somebody enters his or her name. Then you say now start time is equals to process time. So that means now you are prompting the program to process start time, which it will enter to compute the time which a user has entered his or her name. Then elapsed time. Now it is calculating. It will calculate. I don't know why this thing keeps on throwing me out of the Zoom, but I've realized it on time. Now it is calculating the time from when the user typed his or her name. Then after it has calculated the time, I have set this program to give, to print, to display. So it is telling me now, print, it will print the name. Then it will tell me how much time it took to print that name. So when I run this, when I run and I enter a name such as Levi, my name, and I press enter, you see the program tells me now Levi. Now it displays Levi. Levi, it took 0.0 seconds to respond. So it just took 0.0 seconds to respond. So basically what I want you to get is that process time function is used just to calculate time in Python programming. The second example, for example, now I say now from time, import process time. Then now I set, I want to get this summation or some value. I set my sum to be equal to 0. Then the start time, I want now it to process the time it will, the program will take to do this computation. So I say start is equals to process time. Then now I will apply iteration. I say for n in range, I want it to process time that a range from 0 to I think this is 1 billion and something. Yeah, to say the time the program will take to sum all this number between 1 and 1, I think this 1 million. Then I'm telling it to sum. So after it has done the summation, I want it to process now the time. And how will it process the time? It will take the process time minus start, and it will give me all the number of seconds it has taken to do that computation. For if I will run, you see, uh, it is just running, and after it has run, it will give me the number of seconds it has taken to do that computation. So that is the work of a function known as process time within the time package in Python programming. It is just used to calculate the time that it has taken. For in this case, you see the time it has taken now to calculate, it has given me the sum of all the numbers in the range from 1 up to that range, and it has given me now the time it has taken now to do that computation is 25.51 seconds. Why are we using 25? Why are we using seconds? As you all know, the SI unit of time is seconds. So let me, for example, reduce this range. I give it up to 100, and I want it to process the time it will take to do now the summation of from 1 up to 100. That means it is 1 up to 99. So when I run, you see, it has given me the sum is 4950, and it has only taken 0.0 second. And as you can see, it only took 0.0 second because immediately I clicked, it gave me the results. So these are just further examples of processing time. So it tells me now it has the count is 47,643, and it has taken 2.7. So what I want you to basically get it right is that now the work of process time, and this function process time in Python programming, it just measures the computational time a program takes to execute, and it comes from the time package. So that is the basic thing I want you to get. Even I don't want you maybe to measure on how to make those program or what. Yeah, I want you just to know how to import it and how it is applied. Now, the second thing I will in time package is known as sleep function. Sleep function, you see, for example, this sleep function, it is normally applicable when by these watchmaking industries. How is it applicable? Because you see a watch, when normally it counts seconds, it counts second. It will click, then wait, click, then wait. It is an application of sleep function. So for example, you want to count one, then you wait for 2 seconds before you count two, then you wait for another 2 seconds, you count three. You will have to use what we call sleep function. And for you to use sleep function, you have to import it from the time package. You'll say from time import sleep. Then for count in range, 10 to -1. So what does it mean 10 to -1? This means it will start counting from 10 up to 0. It will start counting from 10 up to 0. Then you see here, in a difference, this is just a difference. It will be counting in a difference of 1, 1. Then I want this program to print count. But when it will be executing this program. I want it to sleep. After it has printed 10, how long do I want it to sleep? I want it to sleep for 2 seconds before it counts 9. Then it sleeps for another 2 seconds before it counts 8. All that way up to when it will reach 0. Now look, you see, it has printed 10, then sleep. 8, then it sleeps again. 7, it sleeps. It will sleep. You see, it has been displaying from 10 up to 0, but you can see there was a time difference. When it printed 10, it waited a bit. Then it printed 8, it waited a bit. In that order up to when it printed 0. So for you to observe it very well, let me put 5 seconds. I want it to be sleeping by 5 seconds. So what does it mean? For it to print those 10 value, it will take 50 seconds. That is about 1 minute. So just look, and when it sleeps, try to count on your side. You will see it is sleeping by 5 seconds. Let me start. 10, 1, 2, 3, 4, 5. Then it print 9. Then after it has printed 9, it will sleep for another 5 seconds before it prints 8. After it prints 8, it will sleep for another 5 seconds before it prints 7. So it will go that way up to when it will reach 0. So you have seen. So sleep function, why is it still? Yeah, sleep function is just you are allocating your program a certain time before the program is executed under a certain time. For example, you can decide it is 1 second, 2 second. That is just the under sleep function. So in time package, we have covered sleep and you have covered process time. Then
Levi, sorry, can
yes,
I comment something?
yes,
This sleep function,
yes,
I appreciate it because I can foresee
yes,
in the event that we now master these things and we are doing a project, it
yes.
can be very useful in setting up a system like the traffic lights. You have seen in Nairobi where now sometimes it is slow, sometimes it's very fast the way it is counting.
Yeah, true.
Yeah, traffic. I'm relating this to traffic is something very practical.
Yeah, thank you for appreciating. Yeah. Now, after that, before we are about to go for our first break, so I will not introduce random numbers. I will do it when we come for our second part of the lesson. So up to this juncture, we have covered 3 libraries. The first library, which we started with, was math library. And you realize under math library, we covered square root, we covered sine, we covered cos, we covered exponential, log. All those are under math library. Then the second library we have covered, it is the random. Is the random library. And under random library, it has given us the random function. Then the third library that we have covered, it is the time library. And under this time library, we have seen 2 functions. The first function was process time, and the second function was the sleep function. So up to this juncture, I wanted our break to start at 5:30. I don't know if I can add something here. Now, let us go to random numbers. Some application require behavior that appears random. Random numbers are useful, particularly in games and simulation. So for example, when you want to make games and those simulation, you have to use random numbers. For example, many board games use a die to determine how many places a player is to advance. The Python random module contains a number of standard functions that programmer can use for working with pseudo-random numbers. The first one is random, which we have just covered it briefly. Random, it returns a pseudo-random floating point number, which is, we have seen it is in between 0 to 1. And when I've run it, you have seen it, it has returned a pseudo-random floating point number. And every time I clicked it, it used to give me a different value. Then the second thing we will cover under random numbers, it is rand range. It returns a pseudo-random integer value within a specified range. So in rand range, you have to specify. But you saw in random, we didn't specify. You just write random and you open and close the brackets. Then you have got what we call seed. It sets the random number seed. So you will see now when we will start Python for data science, each and every time I will be setting a seed. And by then, I will not expect you to ask me, why are you setting the seed? For example, when you are running a machine learning model, let me just use a simple machine learning model such as decision trees or linear regression. You have to set a seed. The reason of you setting this seed is that it will enable you each and every time you run your model, it will give you the same results. So a seed, it sets the random number seed. So the seed establishes the initial value from which a sequence of pseudo-random number is generated. So when we will come for our second part of the lesson, I will cover on these random numbers in details. Some which I will see to be more abstract, I will be skipping it. I want only to cover what will benefit you in your certification as per now. Anybody will want something advanced, you might book your class. So I don't want people to run away again. So thank you very much. When we'll come back, I think the lesson will take less than 15 minutes and we'll be through. So let me give you 10 minutes break up to 6:40. Thank you.
Okay, thank you, Mr. Bushuru, for teaching us. I wanted to tell you that I am going to post a link in the chats for it's a form. Fill it kindly. It shows that you are in class. Kindly. Also, when we come back, I will kindly request all of you to put on your cameras for me to take a screenshot and show people that the other half of the class is ongoing. Thank you. I have sent the attendance form in the chats. Kindly fill it. Thank you.
Well, I hope everyone is back. Today I've given you a very long break. Now, before we went for the break, I had introduced you to some function. This first one,
Sir.
we have covered it above there. Yes.
Kindly, please, I would like to request everyone to put on their cameras for me to take a snapshot, and then you can continue. Kindly, please, everyone, kindly
Okay, thank you.
put on your cameras. I would also request that you stop sharing for a bit because I can't see everyone.
Okay, let me stop.
Okay.
Okay, I've stopped.
Okay. Kindly, those who haven't, please do. We need to hurry. Okay, let me just take it. Okay, thank you.
Okay, thank you a lot, Yvonne. Okay, before we went for the break, I had introduced you to three functions that can calculate random number. And the first one is random range, and seed. In random, I told you you don't specify anything and it will generate a floating point number in the range between 0 to 1. But now in rand range, you have, as the name suggests, you have to specify the range, or you have to specify the range. Then seed, it sets up the random number seed. Now let us go straight away to the example, and we'll start by computing the rand range and seed. Now you say from random import rand range. So you have to know this rand range and seed is within the random package. So you'll say from random import rand range, then comma seed. That means you are importing two functions, the random and the seed. Now I'm setting now our seed to be 5. So you see here, I'm setting the seed. That means you are just setting the seed of this random number. For me, I've decided to set it to be 5. Then now I want now to generate these random numbers. How am I going to generate it? So I'm saying for I in range 0 to 100. So that means it is going to print 100 random numbers. It is going to print 100 random numbers. So, and that's why I've written here for I in range 0 to 100. So that means it is going to print 100 random numbers. And these 100 random numbers, I want it to be in a range from 1 to 1000. These random numbers, they are in a range from I had been thrown out. I had been thrown out of the Zoom. I don't know why. Nowadays, this Zoom keeps on throwing me out of the meeting. So what I was saying now, I want to print random numbers, and these random numbers, I want to print 100 random numbers. What will take care of this one, 100 random numbers? I have to give it now an iterative or a loop. And I've decided I've started by specifying this loop. I've said for I in range 0 to 100. It means I want to generate 100 numbers. and these 100 numbers, they are random numbers. How will I generate them? I will have to specify the range of these random numbers. That is why you see I'm saying print rand range. This rand range, this random number should be in between 1 to 1000. Then I just say print with the opening and closing bracket. That means now I want the random numbers in between the range of 1 to 100 to be displayed. So when I run this, you will see it will display for me all random numbers in between in between 0 to 100. You see, it will give me all random numbers in between 0 to 100, and it will give that means it will give me 100 random numbers, and this 100 random numbers, it is in the range of 1 to 1000. As you can see here, you can see a number such as 725, you can see 992. That means I've specified a range. I've specified a range. So when you want to generate a rand range, you have to specify that range. And this range, I've said, it is in between 1 to 100, 1000. What if I'll change here and I say it gives me in between 1 to 100? So when I run, you see it will give me those all random numbers, but these random numbers now in this case, it is in between. It will give me 100 random numbers, but now these random numbers are in between 1 to 100. What if now I retain it to that 1000, but I come here, I put here 50. This means it will print 50 random numbers. Not 100, it will print now 50 random numbers. And these 50 random numbers are in the range of 1 to 1000. So when I will generate, you see, when you count all those numbers, it is 50. Let me make it as small as possible so that you can see. For example, I want 5 random numbers, and these 5 random numbers to be in between the range of 1 to 1000. So when I will run, you see it has given me 5 random numbers, and those 5 random numbers are in between the range of 1 to 1000. 638 is within the range, 262, 760, then 368 and 815. So we have now see how applicable, how we can apply the rand range function and how we can apply the seed function. So what I want you not to confuse, when you are just using random, you don't put any argument. But when you are using rand range, you have to put an argument, and those argument must be two argument. You have to put an argument. So for example, let me create another cell here, and I say rand range. Rand range. Now in this case, I don't put anything in between the bracket. So because I have not put any argument in between the bracket, when I run this, it will give me an error because it requires an argument. It requires an argument in between it. I have to specify the range, maybe 1 to 10. 1 to 10. So when I put it this way, you see it will give me now the range. And how has it computed that range? It has just done the difference of 10 minus 1. And it has given me 9. For example, I put here 10, I put here 100, and I want to get a rand range. A rand range. So when I'll compute, it has given me 13. Why has it given me 13? Because I expected it. Yeah, I expected it to give me 90. So what I want to put across is that rand range, you must put an argument. But in random, you need not to put an argument. So for example, when I write random this way, and I put the same argument such as 1 and 10, it will give me a syntax error. It will give me a type error, and the type error is an example of a syntax error. So when you put random that way, it doesn't expect an argument. But in this case, where when you don't put an argument, it will give you an error. So that is how I want you to get the difference. So the numbers printed by the program appears to be random. The algorithm is given a seed value to begin, and a formula is used to produce the next value. So that formula up there, that iterative formula that I've used, let me cut this one first so that it cannot confuse you. So this iterative formula that I've used is now to specify the number of random numbers that a program should produce. So that is why I've said the program is given a seed value to begin, and formula is used to produce the next value. The seed value determines the sequence of numbers generated. Okay, that is where I want you to get me right. This seed value determines now the sequences of numbers generated. So let us put it, for example, the way it was, such as 100, and then we see, want to see. Now, the seed, as you can see from that description, the seeds it just gives us the sequence of the numbers generated. So identical seed value generates identical sequences. If you run the program again, the same sequence is displayed because the same seed value. No. I want to explain it here in detail. So, as you can see, we have said that seed value, it gives the sequence of the numbers generated. So for example, here I've put it seed 5. I've put it seed 5. So, and you see it has started with 638, 262. So I want to change this seed 5 and I put seed 10. You see the difference. You have to be keen here. You see it has started by 638, 262. What if now I put the seed to be 10? Let me put this seed to be 10. We see if you will have the difference. Now, when I will run with seed 10, at first it started with 638 when it was generating these random numbers. But here you see now it has started with 586. So when you change the seed, let me explain it in a layman's language. When you change the seed, also it will change the values of random numbers that a program generates. What if now, let me put seed 30. You will see also those random numbers will change. Those random numbers will change. So when I run, you see 553. As I told you earlier, why are you supposed to set a seed? For example, you want to generate the same values. You get the same value each and every time you run these random numbers. You will have to decide on a seed which you should put. For example, if you just run this thing without a seed, let me comment it here. Let me comment. By commenting, I mean now I'm running it without a seed. Let us see how it will do. So when I'm running without a seed, you will realize that each and every time it will generate different values. Each and every time it generates different values. You see, each and every time it generates different values. The numbers are not constant. Each and every time I'm running it, it generates different values. Now, when I decide now to set my seed at 30, it will generate the same value each and every time I will be running this program. Just observe. When I run it for the first time, you see the first value is 553. then the second time, the first value remains to be 553. Even if I run it 10 times, the numbers will remain to be the same. But now look, when I don't use seed, when I don't use seed and I try to run, the first value, it is 541. It changes when I run it again, 514. When I run it again, 889. When I run it again, 539. So it keeps on changing. So the reason for you putting a seed, it ensures a programmer gets the same value each and every time you will be running your program. And it will be very, very important when we will be tackling Python for data science. This seed will be very, very important. Just look, for example, you are doing a project. For example, you want to predict population growth. You know, a person who is in Nairobi must get the same results with the person who is in New York or in Kisumu or in Kitale. So what will enable you to get the same results, even when those judges will be running your codes, they will get the same results. When you start that project, the moderators of that project will normally give you the same seed, so that when you will be running your project, it will generate the same results. Even if it will be, you will run it 10 different times, you will have the same results. So that is just the work of a seed. Now, this is just an application of a round range. For example, when you are having that die game, you want to determine the number of those dice, you will apply the round range. But the most important thing for your certification, it is in this cell which I've run. That is the most important. For this other, it is just complex. Yeah, for this other, it is just complex, which I don't want you to strain yourself. The other thing is the importing issue, and I think it is just a repetition of what I've covered. It is just a repetition. For example, you see here, import one or more specific function. You can, when you want to import one or more, I've told you, for example, you want to import square root or the log function, you will say from math import sqrt or import log. But when you want to import everything at once, when you want to import everything at once, you'll just say from math import star. It will come with all functions within the math library. But in this first case, it will just come with a specific function. When you want to get a specific function, for example, you want to get a square root, you will say from math import square root. When you want to get log, you will say from math import log. But if you don't want this repetition, for example, when you want to calculate square root, you say from math import square root. When you want to calculate log, you say from math import log. When you want to calculate cosine, you say from math import cos. You just import everything at once. And when you want to import everything at once in Python programming, you just say from math import star. It will come with everything at once. Then when you want just, there is another way of importing. This is where you import now the package. You import the full math package. You just say import math. But in this one, for example, when you want to calculate square root, you have to start with with the word math first. For example, you want to calculate square root of 16. If you would have imported by saying import math, you will start by saying math.sqrt in bracket 16. Or if you want to get log, you will say math.log for in bracket a number such as 20 or 10. So these are just three different ways of how to maneuver with the math library. But what I encourage you to be going with, I encourage you to be going with this second one, where you don't have to import the function each and every time. This is the end of chapter 6. And what I can say in chapter 6, majorly we have covered 3 libraries. And those 3 libraries, the first library was math. Math, it came with a different function in mathematics, such as square root, tan, cosine, power, all those, they are under math library. The second library which we have done, it is the time library. And under time library, we have covered 2 functions, process time, and the second one we have covered, it is the sleep function. The third one is the random library. And under random library, you have covered the random function, you have covered the rand range, and also you have covered the seed. And I've explained to you in details. The random doesn't require any argument within the bracket. The rand range, you have to give 2 arguments. When we come to seed, I've told you the importance of seed. It ensures that the program gives the similar results whatsoever the number of times you will run that program. So what I need you to note, chapter 6, 7, and 8, it will only talk about function. So this is just an introductory part of function. In chapter 7, we'll learn some more function, such as global functions, but I will just touch some basics part of it, which carries, which goes hand in hand with the certification. And also chapter 8, still on functions. And since I've given you a base and a proper introductory, I think chapter 6 and 7 should not take time, because I won't be giving you those some complex, very complex parts. Just teach you as what you'll get in the certification. Up to that juncture, I want to share it once more. And if any person has got a question, you can raise it. I will really appreciate it. Thank you.
Yes. Can I ask, Levi? Thanks.
Yes, yes.
So from the math function,
yes,
does the time library?
It is not. It is not math function. Math library.
Yeah, the math library is different from time library and also the random library, or they are one and the same thing?
Those are no, those are 3 different libraries.
Okay.
Yes, from math library is where we get the square root, cosine, and time library is where we get the process time and sleep. Random library is where we get the seed. Any other question? Or it is in the charts?
Yes, sir.
Yes,
Levi, I have a question.
Yes.
Yeah, I like the way you have expounded on the seed.
Yes.
But what happens is that I was seeing when you put the seed, you change to 5 and you change to 30.
Yes.
What I was seeing is the first value remains, but the other values. The other values are changing, but I was not seeing the role that the seed is playing, in terms of the sequence.
In terms of the sequence.
I mean, what is the role of the seed? When
yeah,
maybe I ask it. I ask in a different way.
Yes.
Maybe I can ask in a different way.
We can just
Is it that
We can
is it
just
that
go
when
there.
you
This is the
change?
seed, isn't it?
Okay. Yes. Well, my
This is
question
the seed,
was,
isn't it? Yes.
yes, now you change to 5, then you change to 30, and I think 10. So
Yes.
so of course the values could change. The values could change, but when I look at the random values generated, they are not
Yes.
having any relation. So I was wondering, where is the role of the seed? I mean, where is it? From the concept of random numbers, what is its role? Because I was not seeing any pattern in the numbers, despite the fact that I was seeing the first random number becoming static.
Okay, so in layman's language, the seed, when you set the seed, for example, when I've set this seed to be 30, the random numbers that will be
Yes.
generated will be different to when I set the seed either to be 20, 10, or 5. So I want you to note
Precisely.
one thing. Yeah, what is the first number there? It is 553, isn't it?
Yes.
Write it somewhere so that we can go together. Write at least 5 numbers: 553, 828, 297,
Yes.
626,
Then 26.
then 31, isn't it?
Yes.
Now, after you have written, I want now to change this seed from 30 to 20. Have you seen I've changed it? Then let me run.
Yes.
When I run, write the number now for the second bit of the seed. It is 928.
So 741.
741.
703.
703.
806.
806.
785.
785. They are
Yes.
still the random numbers generated with within the range of 1 to 1,000, but you see the values has changed, isn't it?
Yes, yes.
Now let me change it now to
return it to 30.
When
yeah,
I
I want you to return to 30 so that
yeah, let me return it there again to 30. You see, it has just generated the same numbers as when it at first. I think at first it generated this number, isn't it? 553, 828.
Yeah, I can confirm. I can confirm
Yes.
that the first 5 numbers,
yes,
are the very ones that we had initially.
Yes.
So meaning what? I mean, the logic behind the random numbers, because it means what? It means when I set my seed at 30, somebody else sets at 30, then you are going to have the same numbers.
Yeah, when you set your seed at 30, and me, I set my seed at 30, you are going to have the same numbers.
You see, I'm trying to picture the random numbers that we have in a hard copy, like the back of the statistics textbook.
Yes.
I'm trying to relate this sequence. Why this sequence? Why are you getting when you go back to the same seed?
Yes.
Is it following a particular order, a particular sequence, or there's a systematic way of picking these random numbers?
You can just do the computation. Just do 821 and 553. You see how it behaves.
Or you mean we get a difference?
Yeah, just get the difference.
Because when you generate numbers in Excel,
yes,
when you generate random numbers using rand between,
yes,
then every other time you will get, of course it doesn't have the seed, but every other time you will get different values.
Yeah, now Python is more advanced a little bit than Excel. If you want to do the same thing in Python, it can do. Are you getting me? Yeah, in Python, if you want to do, you are saying in Excel, every time you run those random numbers, it generates different values, isn't it?
Yeah, because you simply specify the beginning value and the end value.
Now, what makes this one not to generate different values every time you run it? It is because of this seed.
Yes.
The seed will enable a programmer to generate constant random values every time he runs the program.
Okay, then
for example, just
Python
look here.
should be more advanced.
For example, here, when I run this and I have specified the seed, I want you to be very keen. You see, even if I run 10 times, it will just generate the same numbers. Are you getting me?
Which is okay.
Now, look here. I want to answer your question fully. I want to remove this seed, and it will do exact the same way Excel normally do. When I remove that seed, just look here. You see the first number was 553, isn't it? Let us just concentrate with the first number, isn't it? When I run it, it changes to 106. Is it true? When I run it again, it changes to 541.
Yes.
When I run it again, it changes to 514. When I run it again, it changes to 889. So what prevents it not to behave the same way as now? This is the same if you could have run it in Excel, isn't it?
Yes.
But now in Python, when you want now the random numbers which are being generated to be always constant, even if you run it 1,000 times, now you come up with the seed. You come up with the seed.
Okay, so will I be right to say that the seed specifies how the application will pick the number?
Yeah, you'll be right.
Oh,
so
okay.
Different seeds will give out now different numbers. For example, if I give seed 0, the random numbers which will be generated will be different with the case when I will give maybe seed 5. So you see seed 0, and when I run it, it will just give me the same values, even if I will run it 1,000 times. Now you see the first value here, it has started with 865, isn't it? It will be different. For example, when I give it seed 5, it will be different. The number here will be 638. But this 638 will remain to be the same 638, even if I run it 100 times. So
okay, I think I'm satisfied.
Yes.
Maybe now I think it predetermines how the Python will generate the random numbers.
Yeah, true.
Okay, I think it's okay. I've understood that.
Interesting.
Okay.
It's very interesting.
That is just a slight difference now between Excel and now Python. That is why we normally call Python, it is a general purpose, very strong language. What now you can see, Excel can't do this, but now Python can do what Excel can do, and it can go a step higher.
Okay.
Yes.
Okay, maybe you allow me to ask the last question.
Yes.
Okay.
I share the screen.
Now, the question that I wanted to ask is by default.
Yes.
This by default, this Python program or the compiler, so to speak, which are these functions without importing? I know along the way you'll be importing libraries, whether it is math library, whether it is whatever. But what is this that the application has by default, so that
Yeah.
what is this that can works without importing all these libraries at some point?
Yeah, so the difference now between Excel and Python, for example, I saw in your last lesson, you are also teaching about functions, isn't it?
Yes, yes.
Now in Excel, just say is equals to, then average is equals to if, isn't it? So that is equal to in Python, it is equivalent now to importing. In Excel, when you want to import that function, you say is equal to. But now in Python, when you want to import that function, you say now import.
Okay, that's okay.
Are you getting it?
Yes, that's okay.
Yes.
Yeah, that's okay. My question was,
Yes.
when you open Excel, you will find all the functionalities are all the functions are loaded into memory.
Yes. Yes.
Now, this Python, which are the basic functionalities it loads?
The basic functionality, it has mean.
You have to import every other time, or there are some starting points.
I don't know why you are breaking. I don't know why you are breaking.
My internet is stable.
Yes. Repeat your question, please.
I was just asking about the functionalities that are available.
Yes.
Before you start importing others.
Okay, I've gotten you quite clearly. There are some functionality which are just there. For example, if you want to find me, for example, if you want to find mean, they are just there. For example, if you want to find sum, they are just there. When you want to find kurtosis, when you want to find variance, they are just there. The same way Excel has. It is the same way there are some function which are just there. You don't need to import. What you need to import is, for example, you know in Excel, your data is already in Excel form. But now in Python, you need now to transform this data from Excel to Anaconda environment. That is why now you import. But there are some things such as mean, such as kurtosis, variance, if, else. They are just inbuilt.
Okay.
Yeah.
Thank you.
Any other question, if any? Okay. I see you have exhausted all the questions.
Excuse me.
Yes.
You said that when instead of maybe recalling some functions like in math,
yes,
you simply type import math then star, so that you take care of any other library that you want to pick from math. But is there any other universal way where maybe you want to also import other functions minus now like recalling maybe one after the other?
Yeah, I said there's universal way minus where you don't need to recall. In fact, you don't say import. You don't say import math star. You say from math. You say from math import star. So when you say from math import star, it will come out with all the functions within the math library.
And just a point of clarification,
Yes.
maybe from our the first two classes, we talked about import
Yes.
pandas, import NumPy, and now we also
No, I
talk about
told. Okay, yeah, you should not be confused with those import pandas and NumPy. I told you that is not within now this Python programming, because anybody to come in a programming class, you should at least know how to import data. That will be taught in details under Python for data science. Those are packages under Python for data science, where we say import pandas as PD. Pandas is a package for importing data. Then we say import NumPy as NP. NumPy is just numerical Python. It does all numerical calculation in our data. That one, it will be taught in detailed under Python for data science. This should be in our next class, which will start, I think, from October. Python for data science. So that is now for analysts when you have now started analyzing the data. But here we are just learning purely programming. Okay. Have you gotten it? Yeah.
Yes.
Is there any other question? So if there is no any other question, I can confidently say this is the end of our chapter 6. Next week, I will introduce you to chapter 8. I will skip a little bit chapter 7, but I will come back to it because my Jupyter notebook for chapter 7 got crashed. So I will need to prepare another one. If by the end of next week I will have prepared, I will teach you that chapter 7. But now I want to give you you to know that from this chapter 6, 7, and 8, it will basically touch on functions. So for example, in this chapter 8, let you just look at it a bit. You look at what we will cover. In this chapter 8, it will talk more on functions. And when it will talk more on function, there is what we call the global and local variables. When as a programmer, you will know how to define function. You can make your own function. You can make your own function and use it. This is where now you will be defining your function. Even in some instances, you can make your own function. For example, you can make a function which can visualize an Instagram, a pie chart or what, and even you start selling them. So this is where now you as a programmer, you will learn, you will get the basics of how now you can develop your own functions, And this one will cover it under more function. So we will use the definition, and you will know how to define function in Python programming. We normally use a def function. So when you see somebody tells you def function, DEF, that is just definition. So you will know how to define functions and how to, you can enter different number arrays in those functions. So chapter 6, 7, and 8, it will talk only about function. And I think it will only, this one also, it will take one class, and then I'll return to chapter 7 also. It will take another one class. Then the last 4 chapters, it will be very brief, because in chapter 9, we learn about list, how to index a list, how to slice a list, and that way. And I think when we'll be through with around chapter 9 or 10, in fact, chapter 9 will be in a position to handle that certification. Those other chapters, it is just, I think it is just like a bonus. But when we'll be through with chapter 9, we'll be in a position to handle those certification. And also, I'm considering that I'm only going with the content in that certification. That is why you will realize when I get a very complicated example, I skip it so that I can adhere only to what is given to the certification. Thank you. Thank you a lot. So this is now the end of our lesson.
Okay. Thank you, sir. Thank you all for attending the lesson. I hope you filled in your details on the form. Okay, Dennis is saying, kindly share the notes. If we get the class recordings by tomorrow, it will be of great help. Because I had, okay, fine, I will send the class recordings. Thank you, everyone, and have a good evening.
Okay,
I don't know. Do you have all the slides up to chapter 6?
Yes. So if I sent you the slides,
yeah, I think you have got all the slides.
Yes, you have. Okay, thank you.
No, I don't have 1 and 2. I requested and I've not got.
If you have
Yeah, let me just send for you right away.
Okay.
Yeah, let me send for him right away, Yvonne.
Okay.
Because people normally request, and because
Why
of
don't
my
we
tight
why
schedule,
don't we
sometimes
send
I
all of
forget.
them? Why don't we send all of them again? Because I'm not sure we have all of them.
If you have, okay, send.
There's no problem. All these things are
Just
just
send
I
all the
can send them,
slides.
all of them.
All right.
Can send all the slides. Don't worry. It is from chapter 1 to 6.
Then Yvonne, you can also organize to put together the recordings in a way that it can flow. That will really help, so that we revise together with the slides.
Okay.
I think they're coming.
Yeah.
Okay, so, oh, you have sent. Thank you for sending.
Yeah, I've sent all of them. I don't know why the first one is not coming. Yeah, I think they have come, all of them.
Yes, yeah, now in a very good order. Yeah.
And let me send for you in advance the Jupyter book for chapter 8 so that you can be passing through it. Don't know what is the problem with my WhatsApp. So the netbook for chapter 8, let me send it this year. I've also sent the notebook for chapter 8. The chapter 7 one crashed. I'm making a new one. So when it will be ready, I'll just send. And someone might ask, what is the purpose of a notebook crashing? In our last class, I told you when your notebook has got a lot of infinite loops, when it has infinite loops, it causes it to crash. So my last notebook, the chapter 7 notebook, had a lot of infinite loops. So that is why it caused it to crash. So when ensure your notebook doesn't have a lot of infinite loop. When you realize you have got a lot of infinite loop, try to subdivide them, because when you have a lot, it will just crash. Thank you. Have a good day.
Okay, thank you, sir, for teaching and for sending. If there is anyone with an issue, kindly you could reach out to me. I will help you. Yes, that was our class for today. So if there is anyone with no issue, have a nice evening. We will meet in the group if you have any questions or anything. Thank you.